Hello everyone, welcome to my channel. Right, in this lesson we are going to see the continuation of algebraic processes. Now, in particular, we are looking at algebraic fractions. All right, so when we have fractions containing variables, we refer to such fractions as algebraic fractions. Okay, so we are going to see, for instance, if I have something like 1 over 2x, this is a fraction and it contains some variables, the x, and so you say it is an algebraic fraction. So you can have something more, let's say 3x all over 5, maybe minus y over say 10, something like that. So this is an algebraic fraction. So once you have a fraction that consists of some variables or one variable, you refer to that fraction as an algebraic fraction. Okay, so the objective of this lesson is that by the end of the lesson, you should be able to do simplification of algebraic fractions into their lowest terms. We should be able to do operations such as addition and subtraction of fractions, something like this, multiplication and division of fractions, and so that's board mass. You should be able to open brackets, which we've already done under expansion and factorization of fractions. And so we should be able to deal with simple equations involving fractions. We should be able to do substitution into algebraic fractions. We should be able to solve simultaneous equations involving fractions. We should be able to solve problems involving undefined fractions. That is to say, what does it mean for a fraction to be undefined? We are going to see that. And lastly, we will see what it means to say that a fraction is equal to 0. All of these are simple and beautiful concepts which we are going to see in our subsequent lessons. But in this particular lesson, we are going to start with the first concept, which is simplification of algebraic fractions to their lowest terms. Okay, so let's go. Okay, so we want to look at some examples on simplification of algebraic fractions to their lowest terms. All right, so how do you do that? Very simple. In most cases, of course, as fractions, what will happen is that there will be common terms in the numerator and in the denominator. So it's just like normal fractions of numbers. For instance, if I have 4 all over 12, okay, so you know that this fraction can actually be reduced to lowest term. And how do you do that? You do that by dividing the numerator and the denominator by a common factor. Okay, so of course, you know, in maths, whenever you have a fraction, whatever you do to the numerator, you must do to the denominator. So if I divide this, say, by 2, I'm going to get 2. If I divide this one by 2, I'll get 6. This is, however, not in its lowest term yet. So I will still need to get divide again by 2, which will give me 1. And then I'll divide this by 2, and that will give me 3. All right, so that means if I can get the highest common factor of the numerator and denominator and divide by that, that would actually help me do it immediately. All right, so the same is applicable when it comes to algebraic fractions. You look for their common terms and divide both numerator and denominator by that. So like this simple example here, I can see x in the numerator and x in the denominator. So I've removed that. I can see z here. I can also see z here. And so very simple. This is the same as y over w as your answer. That's been reduced to the lowest term. Nothing else can divide the numerator and denominator. Of course, that's the meaning of reducing to lowest term. Okay, so what about this other example? Say you have 6a squared c. So what do? Here you can see you have numbers in both numerator and denominator. So you begin to look for the for what, which is actually the HCF. All right, so that's actually one way you can do this. You can look for the HCF of both numerator and denominator, but that may take you a lot of time. So you just go ahead and look for what can divide through. Like for the numbers, 2 can go. So 2 into 6 is 3. And then all over 2 into 8 is 4. Okay, so you can see how I'm doing that gradually. So here now, A can go. So A divide A, it will go. And then in the numerator, A divide A squared. 1A will be left. So I have A left. And then here, C can divide C, and that will go. So B is left. Nothing up can cancel B. So I just have 3A all over 4B as my answer. Okay, so while here, of course, you can write this 2 here is 4. So you bring it out. So what do you do there? So the same. So you look for the numbers, you look for their common factors, and then for the alphabets too. So here, I can see 7 can divide into 21 and divide into 28. So I can quickly do that. 7 into 21 will give me 3, and then 7 into 28 will give me 4. So I will come up, I'm done with the numbers. So I come for the alphabet. P here is 1. P into P squared is 1P. So I have 1P. And then nothing can divide Q in down. So the denominator does not have Q. So I will return my Q squared the way it is. Now for the R can go. So R squared. Remember that R squared is the same thing as R times R, and R raised to the power 4 is the same thing as R times R times R into 4. So here will cancel here, this will cancel this, so you have only one up, while here you have 2. That's R squared. So I can come down and write R squared. So R squared divide R4 will give you R2. Okay, so you have only R squared left. So that is giving us 3pq squared all over 4r squared as the answer here. Okay, all right. Okay, so the other example, okay, beautiful. How do you simplify this into its lowest form? Remember, like we said, that you are looking for the common factors for the numerator and the denominator so you can cancel them out. So what do you do here? This is why it was necessary that we do the lesson on factorization before coming here, because you would need to factorize both the numerator and the denominator. And in case you've not seen that video, I'll put the description to the video in this other one. I will put the link, sorry, to the video in the description of this other video so you can see that. All right, so what do? We'll factorize the numerator by bringing out the common factor. So there is u here, there is u here. So I'll bring out u, and then open bracket, u divide u squared will give me u, plus u divide uv, you have only u left. Oh, sorry, only v. And that is over. Now, what about this? This one now is difference of two squares. We also handled it under that factorization lesson. All right, so, and we said that when you have difference of two squared, that if you have a squared minus b squared, that it is simply equal to a plus b into a minus b. So since I have u squared minus v squared, that will give me u plus v into u minus v. Beautiful. And immediately you have done that, you can actually see clearly that you can now see some common factors in the numerator and the denominator. And all you need to do is to remove them. So I'll cancel out this u plus v, will cancel out u plus v. And so my answer will now be u. Remember, this will be 1, 1. So u times 1 is u. All over 1 times this will be u minus v. And that is the solution. All right. So some of the mistakes students make, like I said, you are going to see a video on that. Somebody can actually see this and say you can cancel this u, and then we'll say your answer is 1 all over 1 minus v, maybe 1 here. So please, that is what? Completely wrong. So you just, because the reason is that this u below is subtracting v. So you cannot just come and cancel it with this. You can only cancel with this if it is a multiplication. We are going to look at that as we continue. All right. Okay, so this is similar to what I just said now. Someone can mistakenly cancel this AB with this. That is not correct. So what are you supposed to do? Now, you can only divide if what you have up is multiplying, or what you want to cancel is a multiplication. Assume that this is AB into A squared, something like this, all over AB. Then you are allowed to cancel this. Why? Because the AB up is multiplying A squared. So for you to cancel, you must produce a product. That's why we did factorization. So for us to do a cancellation here, I can either, although there is also another method which I'm going to show us. So but here, the simplest thing to do is to factorize the numerator. If I factorize the numerator, there is A here and there is A here. So I can have A out. Then A divide A squared is A, minus A divide AB will give me B. And that is all over AB. And so at this point, I can cancel out this A with this. Why? Because this A is multiplying the whole of this, and this other A is multiplying this B. So you can divide a multiplication. And finally, our answer will be A minus B all over B. Okay, right. So that is the approach to use. However, I said that there is another method, which is, we are going to see that under operations involving fractions, where you have addition and subtraction of fractions. Now we are told there that if I have A plus B over C, that is actually the same as A over C plus B over C. So that means I could have written this as A squared over AB minus AB over AB. And if you do that, this is going to give you, of course, A will cancel one A here, and then this will cancel this to give you 1. So this is going to be A over B minus 1 over 1. Of course, it's over 1. And then you take the LCM. When you take the LCM, it will give you back this. But like I said, this LCM, addition and subtraction of fractions, we are going to see in our next lesson. So the best approach here is to use this, since we have already learned how to do factorization of algebraic expressions. Right? Number 6, let's say we have something like this is going to give us so what's the common factor in the numerator? 4. Okay, sorry, 8. 8 can come out here, so I can have 8 into x plus y all over. The common factor in the denominator is 6. So 6 into x plus y. And you are done. What do you do here? X plus y will take away x plus y, and you have 8 over 6, which is not yet in its lowest form. And so 2 can still go into this. 2 here is 4, 2 here is 3. And so my final answer is 4 all over 3. So you must keep dividing by common factors until nothing else can divide. That will give you the lowest term that you're looking for. Okay, so we'll do a few more examples. So the next example here says u cubed v minus 3u squared v squared all over this. So what do you do here? Now, once you have an expression where there is a subtraction or addition, and maybe whether in the numerator or in the denominator, you should know that factorization is needed so that you can form a product where you can actually cancel something. So here now, I'm going to look for how to factorize, and to do that is to look for common factors here. So here I'm seeing u cubed, here u squared. And so what is a common factor between u cubed and u squared? That is what? U squared, the smaller one, because u squared can divide this and also divide this. So I'm going to bring out u squared. Okay. Now I have v here and I have v squared. So between v and v squared, what's the common factor? That's v, the smaller one. V can divide v and also divide v squared. So I'll bring out v. Alright, so I think that's all for this. So I will open my bracket. So if u squared v divides this, you will have only u left, because v will cancel v, and u squared cancelling u cubed will give you only one u left. Then minus here, u squared cancels u squared, it goes away. V will cancel v squared to remain only one v. Meanwhile, nothing cancels this 3, so I'll bring it down. So this one will remain only one v, and I will close my bracket. Then all over, what happens in the denominator? You also look for the common factor. Here, 3 is not here, so 3 is not a common factor. U is here, u squared is here, so u is a common factor. So I'll bring out u. Now v cubed and v squared. V squared is the smaller one. I'll bring out v squared. So I'll open my bracket. 3 is going to remain here, and 1v will remain here. Okay, minus here, if u divides u squared, you have only one u. If v squared divides v squared, that will cancel out, so you close your bracket. All right, so what do we do here? How do we finish up? Is there anything we can cancel? Yes, of course, there is. Now, you are going to do one or two small arithmetics here. And what is that? Watch what we are given, or what we have. We have in the bracket u minus 3v, while below you have 3v minus u. So they are the same terms. The only thing is that they are altered. Okay, so what do? You will need to reverse one of it so that two of them will look alike. But you don't reverse it just like that. And I'm going to show you the simple thing to do there, and then I will show you the maths involved. So what's the simple thing to do there? Very easy. If we want to revert the denominator, see what we will do. So this one will remain the same, into u minus 3v all over. Okay, so to revert the denominator now, all you will do is turn this way into u minus 3v. However, you will bring out a minus sign to multiply this. So see what I'm saying? I will now have minus uv squared into u minus 3v. How did I get that? Watch this. So you have 3v minus u. I'm showing you the maths there now. So what I just said here now is that this is the same thing as minus u minus 3v. How? Is it true? Yes, it is. If you open this bracket, minus times u will be what? Minus u. And minus times minus 3v will give me what? Positive 3v. So if you now turn it again, remember I usually say, if you watch the video on factorization, I said it there, that once you have negative and positive, that you should rearrange. Let the positive come first. So if I put it this way, I will get back this. So this and this are actually the same. All right. So, and by the time you now join this with this one, so the negative sign is what you have here. So that's actually how we got that. And immediately you do that, you can see that this and this are now equal. And so we can cancel out that. And when we do that cancellation, what are we then going to have left? So we'll just have u squared v all over, this negative sign can come up, so all over u v squared. Okay, so that means this is not yet in its lowest term. There are things that can still cancel. So u can go 1, u here, u, v here 1, v here, v. So finally we have u times 1 is u, all over 1 times v is v. And that's your solution. So you could see that this big algebraic expression is actually the same as u all over v. All right, so understanding your factorization and how to do this kind of rearrangement will help you go through examples like this very easily. Number 8. So suppose you have x squared minus 2x all over x. Now, when you are given this kind of algebraic fraction to handle, you are looking at your denominator in this case. So, but watch what I'm saying. I have x here in the denominator. So, I will look for if there is x as a common factor in the numerator. Why am I looking for x? So that it will simply cancel out this and the fraction will go. And that is possible. So, I have x in the numerator as a common factor. So if I bring it out, here we'll have only x, minus here you will have only 2 all over x. So watch what happens now. X will take away x here. So you just have x minus 2, and that is your answer. Okay, so these are the exercises, but I think I'm going to do number 3, and then I will allow you to do the other 2. Or should I allow you to do all? Okay, let's do number 3 together. All right, so and the reason I want us to see number 3 is because a number of students would do this, in a wrong way. And for instance, you have a squared minus b squared. We have seen this in indices. You can as well see it, in my video on indices. This is not the same as a minus b all squared. A number of students do this, and even when you give them a minus b all squared, they simply distribute the power on the numbers and just on the alphabet and just give you a squared minus b squared. This is not the same. Okay, they are not the same. So, and that's what I mentioned earlier in one of the examples we already did. All right, in this video. So we said that this is called difference of two squares, and it's simply the same thing as a plus b into a minus b all over. Now, square here means, if you have x squared, is the same thing as x times x. So if I have a minus b squared, that means a minus b times a minus b. And that is it. So this will take away this, and your answer is a plus b all over a minus b, and you stop there. So help me see your solution for the number 1 and number 2. Of course, this is where we end it for this video. Kindly subscribe to our YouTube channel. We'll see you in our next lesson.